Welcome everybody. Today we're going to be talking about the different types of GPU clusters, and we're going to have an analysis on each of them to see which one is best. My name is Andy Kuang.
I'm Aglay Saenz.
And I'm Jesse Birbal.
And this is our presentation on the GPU clusters. So GPU clusters are a bunch of GPUs put together, and we're going to be investigating this topic. So the reason that it's used is for boosting performance for large-scale tasks. Also, we'll be researching different types of clusters in the field to see which one best performs in certain situations. So GPU clusters, as I mentioned before, are a bunch of GPUs that are put together. So we want high performance GPU clusters to maximize the amount of power of capable tasks that we can complete. So there are very strenuous tasks that we need to get through. So this is the reason why we would be using them. It also helps with the load balancing, that it's able to handle a large amount of tasks at one time. So some of the types of clusters include heterogeneous and homogeneous clusters. So heterogeneous clusters they have different models, but they all use the same GPU to perform that task, while homogeneous clusters, they have the same hardware, make, and model to perform the job at hand. All right, so next we have Aglay, and she's going to explain our motivation behind picking this topic.
All right, so our motivation for this survey was to have on record the similarities and differences between different GPU clusters. GPU clusters are essential for having a higher performance and a faster computer, but different ones specialize in different tasks. For example, along with what Andy said, homogeneous and heterogeneous GPU clusters, there's also high performance GPU clusters for more demanding tasks, while load balancing GPU clusters handle larger amounts of tasks. We would like to go more in depth, though, and see how they compare to each other even within their own category. So we're not very familiar with this topic, so we have set aside a plan to ensure we get this survey finished before the deadline, and those steps include studying the relevant material online, understanding the basics of GPU clusters, learning what differentiates methodologies between them, recording and documenting our findings in a literature survey. And to summarize the topics that we will be studying, we will be doing the following, which is high performance GPU clusters and how they handle big data, load balanced GPU clusters and how they handle tasks and delegate them, and GPU cluster architecture in general. And now Jesse will explain the workload that we will be doing.
Okay, awesome. So for week one, obviously this week, we're going to do a little bit of research and submit our proposal and presentation. And then week 2 and 3 will probably be the most important weeks, as we will be collecting data, doing research, and learning more about the topic. So hopefully more news comes out about upcoming technological advancements, and we'll talk about more of that later. Week 4 is when we will summarize our research and start working on our literature paper. And then week 5 will be our final presentation. So as for the focus areas, we haven't really done enough research to accurately depict our focus areas. But for now, I feel like splitting up the different types of clusters and then explaining the architecture and software within the clusters is a good idea. So to summarize our proposal, we'll mainly be focusing on GPU clusters as a whole and comparing the clusters themselves, as well as different types of clusters. And throughout the week, we should be able to collect a lot of data and information. And especially now that Intel has just had their investor meeting, they just announced their Arc GPUs, which will be based on their Xe platform, and they'll have notebook cards, desktop cards, and workstation cards released throughout the year. So these cards will include something called Intel Deep Link that works like NVIDIA NVLink, but it allows the CPU and GPU to work in collaboration, which is they call hyperencode, which splits tasks for big data, which in turn gives a performance boost. So our final presentation should have a considerable amount of information and data that we will be able to share. And we look forward to researching our topics. And that ends our presentation. Thank you for listening.